All right, day one for section 4.3. Here's the two learning targets we'll be focusing on. I can solve a right triangle using trig functions, and I can use the special right triangles to evaluate trig functions. All right, so we're going to take the right triangle spin on trig. You should have seen a lot of this before in your geometry class and maybe even a little bit in algebra 2. So there's an acronym for ways we remember the sine, cosine of tangent when dealing with just a right triangle. Okay, remember in 4.2, we had the XYR definitions we could use for any angle in the coordinate plane. And those aren't going to go away. We're still going to use them. But now we're going to kind of also use these at times. Okay, so remember, we like the acronym SOHCAHTOA. You got to know how to spell SOHCAHTOA, though, if you want to use it. So it's SOHCAHTOA. SOHCAHTOA. All right, so what does that mean? That means if we have the sine of an angle, so if I had added details to that, I'd squeeze in a little equal sign and then do an O over H, kind of like that, right? Or it's kind of completed down here. Sine of an angle equals the opposite side divided by the hypotenuse. And I'm just abbreviating these words, right? So opposites. So if I'm looking at angle theta here, you got to understand the opposite kind of means across from that angle. So this is the opposite side theta, and then the hypotenuse obviously is opposite the right angle or the longest side. Okay? Cosine is equal to adjacent over hypotenuse. So ADJ I'll use for an abbreviation, but the full word is adjacent. Adjacent means next to, but not the hypotenuse. I'll say that again. The adjacent side means next to it, but not the hypotenuse, because you kind of have two angles here that are next to theta. Okay, so up in our acronym, again, it's kind of like a new one now. So cosine equals A over H. Okay, and then tangent theta is equal to the opposite over the adjacent. All right, so tangent equals opposite over adjacent. Okay, and that's where kind of those letters come from, right? S, I guess if I were to highlight them, SOHCAHTOA, S, O over H, cosine A over H, tangent opposite over adjacent, okay? Okay, and then the reciprocal relationship is still the same as it was from section 4.2. Cosecant is reciprocal of sine, so if this is O over H, this is going to be H over O. Secant will be the hypotenuse divided by the adjacent side, and cotangent is going to be adjacent over opposites. All right, so hopefully that's a little bit of review. If you didn't master it in the past, hopefully this is your chance now to get this mastered and get it down. All right, so number one, find the exact values of the 6 trig functions of the acute angle theta. So theta is marked here. So as soon as they mark theta, the opposite and adjacent and hypotenuse are now established. No matter where they put theta here or here, though, this has to be the hypotenuse side right here. So this is the hypotenuse. Since theta is here, this becomes the opposite side, and this becomes the adjacent side. Okay. All right, now I can't find the exact values of the 6 trig functions until I find the missing side. Okay, but we can do that whenever you have a right triangle and you have 2 out of the 3 sides. We can use the good old Pythagorean theorem. So here's a reminder on Pythagorean theorem if you need it. I'm abbreviating this too. Okay, so the Pythagorean theorem says leg squared plus leg squared equals the hypotenuse squared. Okay. Sometimes we say a squared plus b squared equals c squared, which is fine as long as you know the a's and b's are legs and the c is the hypotenuse. But when I refer to this, I'm usually going to use these terms so that we're not confused by the variables, just the concepts. Okay, so we need to find this unknown side. I'm just going to call it x. So leg squared plus leg squared equals the hypotenuse squared. All right, and then we just got to solve this problem, right? So this is 36 and 100, so I'm going to subtract this 36 from 100 to get x squared equals 64. And then we take the square root of both sides, so it would be x equals plus or minus 8. But we're dealing with a triangle, right? So we'll throw out the negative. Okay, so this side is going to have a length of 8 now. Just write it in over here so you can see it when we start setting up these trig functions. It's a Pythagorean triple if you noticed it. Okay. All right, so now I'm ready to go ahead and answer these. So let's just start right in the order of SOHCAHTOA. Sine of angle, unknown angle theta is equal to the opposite side, 8, over the hypotenuse by definition. So it's 8/10. You'll probably be expected to reduce these, so we'll just call that 4/5 once we divide them both by 2. On the cosine, so ca, so a over h. So the adjacent side over the hypotenuse. So that's 6/10. 3/5. Tan theta is equal to opposite over adjacent by definition, right? So 8 over 6, which is 4/3. Okay, and then the reciprocals, let's just flip them over. I mean, do we have to go back from scratch and think about the definitions? Probably not, right? All we got to do is take the reciprocals if we know that. Know that relationship, that is. So cosecant must be 5/4 and sine is 4/5. Secant theta is 5/3. And cotangent is 3/4. Okay. So number 2, this one you should be able to do this now on your own. You end up with a radical for the hypotenuse. So maybe in 30 seconds, resume the video and check to see that you found the unknown side correctly. And then I'll have you find the trig functions. Go ahead and find the missing side first. All right, so we got leg squared plus leg squared. These are clearly the legs. We're missing the hypotenuse. You can call it hypotenuse in your setup or just call it a variable x, or you can call it c. Doesn't matter. 1 squared plus 2 squared equals c squared. So that's 5. Take the square root of both sides, and we get for the hypotenuse plus or minus square root of 5. Now, if you don't want to write the minus anymore, that's fine because we got a triangle, right? So we're going to say positive square root of 5 is the hypotenuse. So maybe even draw it in there so you see it. All right, and you push you in the right direction on sine, it's reciprocal, and let you finish the last 4. So sine theta equals, now they can always change the location of theta. Obviously, they can't put it in the right triangle area, but it could be one of these two. So now that theta is here, the opposite is over here. It's 2. So 2 over the hypotenuse square root of 5. Then rationalize it. We forgot to do this on the quiz. Make sure you get the radical out of the denominator. It's just the expectation. So we have 2 square root of 5 on top, and then square root of 5 times square root of 5 is square root of 25, which is 5. Check to make sure 2/5 is reduced. It is. Okay. All right, now here's a little trick here for cosecant. The long way to figure this out is to flip this over. So don't write this down, just watch it. So if I take the reciprocal of this blindly without thinking about it, I'd have this, which is fine. And then I'd have to multiply by square root of 5 over square root of 5 to get rid of that. And then square root of 5 times square root of 5 is 5. 5 times 2 is 10. And then on top I have 5 square root of 5. Okay, but then this can be reduced because 5/10 is 1/2. So I eventually get square root of 5 over 2. Okay, here's the wise way to do this. Right away, when we got sine is opposite over hypotenuse, why don't I flip that over now to hypotenuse over opposite? And right away, I get square root of 5 over 2. So it's just a little time-saving trick if you get used to that. Otherwise, if you flip this over again, you got to rationalize it like I did, which still works, but it's much easier to flip it over now before you rationalize. Okay, does that make sense? That might happen on one of the other ones. See if you catch this time-saving trick. So pause the video and try the next 4. All right, cosine is adjacent. So 1 over square root of 5. Here's the time-saving trick. Flip that over right now to get secant. Square root of 5 over 1. Okay? So then you rationalize it to get this for cosine. If you didn't see that, then you'd have to flip that over and then rationalize secant as well. Okay? But might as well just do it right now. All right, tangent. Opposite over adjacent. So 2 over 1. That one worked out pretty easy. Cotangent's 1/2. Okay, let's turn the page. Look at the next example. Okay, it says sketch the right triangle corresponding to the trig functions of the acute angle, and then find the remaining trig functions of theta. All right, so for 1 and 2, they already set up the triangle for us and got it going for us. But in this case, we need to get the sketch going on our own. And we can do that because we know the definition of tangent. So we're kind of working backwards to start. Tangent, by definition, is opposites, I'm going to write this down right next to it, over adjacent, right? The SOHCAHTOA part, T-O-A. So now I know that the opposite must be 4, and the adjacent side to theta has to be 3. So let's just create a generic triangle over here showing that relationship. Okay, it doesn't have to necessarily be to scale. Don't worry about it. Just draw a right triangle. And you can choose where you want to put theta. Okay, I'm going to put it right, actually, I'm going to keep it to scale. That looks longer. So I'm going to put theta here, wherever you want. One of those two. Okay, so since the opposite side has to be 4, opposite this side theta, I'm going to put 4 here. The adjacent side to theta, remember I've got 2 sides next to it, but it can't be the hypotenuse. So 3 must be here. And then just double check your answer like we did on problems 1 or 2. What's tangent of that? 4/3. Matches up. We're good. Okay, so to find the other trig functions, we need to find the missing side. It's the hypotenuse. This is a 3, 4, 5 triangle. If you have that memorized, great. If not, we could verify by doing leg squared plus leg squared equals hypotenuse squared, right? So 3 squared, I don't know, maybe I should put it by my triangle. 3 squared plus 4 squared equals c squared. You solve that, you're going to get 5. Okay, so that's our missing side. Okay. 4, I'm going to help you a little bit with the math, but you go ahead now and find the other 5 because it says find the remaining trig functions. They already gave you 1. You got 5 more to find. Pause and do that now. Okay, there's your feedback. Fix what you need to. And there's the 5 remaining trig functions. Okay, let's look at 4. Now I'll just start off with the reciprocal function. So for you guys to best process this, you might want to get cosine right now. That's what I recommend, right? So cosine theta is the reciprocal of this, 21 over 24. Okay, and just like we did for this other one, what's the definition of cosine? Cosine is A over H. It's adjacent over hypotenuse. So now I have a value for the adjacent side. I have a value for the hypotenuse. Let's set up our triangle and then find the unknown, and then we can figure out the rest. All right, so I'm going to squeeze in the triangle right here. Like I said, it doesn't matter which angle you want to call theta. I'll drop it down here this time just to mix it up. And what's the adjacent side to that? Right here must be 21, and then the hypotenuse is opposite the right angle, 24. Okay, so we're missing this other leg. I'll call it A this time. So leg squared plus leg squared equals hypotenuse squared. Okay, so if you want to, skip some of these steps, basically I subtract that number to the other side. I better pause right now.